Hi, everyone. Welcome to Tech Talk, a podcast where Amit and we talk about various technology-related topics every week. This week, we're going to talk about a topic called noise cancellation. Noise cancellation, off the bat, it might sound like a very generic topic, but it has a lot of technical aspects behind it. And I think one of the important part when talking about noise cancellation is to define noise as well. Because one of the first things that we do is whenever we talk about noise cancellation, we talk about white noise, like when we're talking. But even music can be noise. For example, now that we're talking, if there was background music playing, that we would count as noise. So a lot of it is context dependent as well. And this and also the technology that goes behind it, we're going to talk about it all today in our episode. Thank you, Amit, for coming up with this topic. I'm very excited to talk about it and learn from you as well, because I know less about it than yourself, I think. So let's start. What's your take on noise cancellation, Amit?
Thanks so much again, Rinat, for that good introduction. I think it is important to first define noise, but the reason I wanted to talk about this topic now is there is a lot of noise around us. There is noise from vehicles, there is noise of constructions that are happening around us, there is noise in the transportation systems. So in London, we have the underground system. There is a lot of noise when you travel underground. Then there is noise from music, as you said, it disturbs. There is noise in the house from washing machines to say vacuum cleaners running. There is the constant noise from different types of machines, etc. And these are the different types of noises that we want to cancel, so we can have a very good experience whenever we are trying to do something, be it working, be it reading a book, be it just traveling and having a relaxed time, or even sometimes sleeping. So that's why I selected this topic of noise cancellation.
Yeah, very much so. I mean, there are so many different aspects of noise cancellation, and the technology that goes behind it is also very interesting. And I remember when I was doing my postgraduate diploma in control engineering, a big part of it was noise cancellation, and there was high pass filters and low pass filters and how to use them to cancel different specific type of sound with specific frequency. And
Yes.
that's just scratching the surface of noise cancellation. And then there's so much more that goes on in current technology, especially in video conferencing. I mean, we're using Zoom to record this topic, this episode, but I've also known about other products available for video conferencing and other communication tools, which also actively always engages noise cancellation technologies to give us a better experience when we're communicating. And audio is very powerful when it comes to communication. Even not just communication in terms of when we're talking, but also when we're listening to a story, listening to a speech or a talk, or even music. So music can be noise when we're talking, but then when we're listening to music, there could be other noises, and
Yes.
canceling all of these so we get a better experience, overall experience, is very important. And noise cancellation plays a big part. So how did it all start? I'm sensing there must be a point in as we advanced in our technology and started using communication or consuming contents, there was a point that okay, so we need to do something about the noise to to for a better experience for consumers. So how did it all start? Do you know, Amit?
So one of the stories that I've been reading is that noise cancellation started with aircraft pilots. So the aircraft pilots, they have to listen to the communication with the air traffic controller, and they have to fly the plane. And the aircraft engines, they make a lot of noise. So if you have ever flown in a plane, then you would know that the aircraft engines make a huge amount of noise. And to communicate with that noise in the background, it's quite important that you cancel those signals or cancel that sound, and be able to listen to what the air traffic controller is telling you, and then able to perform certain actions. So that's where it all started. And if you have seen racing cars, if you have seen Formula One, then in Formula One, what happens is you have a lot of people, the mechanics from the team, they are at the paddock and they are listening to the, or in the pit, as they say, they are in the pit lane, and in the pit lane they are communicating with the drivers, and the F1 cars, they make a huge amount of noise, and that noise has to be first cancelled so that they can talk to the drivers and communicate to them where they are in the whole race, what's their position, how much fuel do they have, how is their car functioning, and the drivers can talk back, etc., etc. So it's very important that in such high noise environments that you have a way to cancel the noise and then be able to communicate. And there are two aspects of it. One is the noise cancellation at your mic. So I'm currently wearing a headphone. It doesn't have noise cancellation, but it has it's over the ear headphones. And so those of you who are watching the video, you can see that I'm wearing a over the ear headphone. So it's covering my whole ear. So that's sometimes called as passive noise cancellation. I have some kind of foam around my ear that's not letting all the ambient sound entering my ears, but the sound is still coming in. And then I'm talking through a microphone, so the microphone itself is picking a lot of noise. So that's why a lot of times when you're on a Zoom call or Google Meet, it's important that you mute your mic. So in this case now, Rinat has mute his mic so that the noise from his side is not picked up from the microphone. Otherwise you'll not have a very good experience listening to this podcast. So these are the two main types of noise cancellations. One is for your hearing and one is for your speech, and it is very important that they are both cancelled. Now, when we talk about noise, the human hearing or hearing in general is measured in decibels. So up to 85 decibels is good enough for human hearing. Anything higher than that, it can cause ear damage and sometimes permanent ear damage, and that would mean hearing loss. That could mean tinnitus. I have tinnitus, so I just wanted to share it with everyone. So it's a ringing sound in your ears, and that's constantly there. It's uh, it's there 24/7, 365 days of the year, and I've had it for a couple of years now. And I had spoken to my doctor, and they said that it's because of some high frequency noise that I was exposed to. It could be the noise from a firecracker. It could be the underground, the tube that I take in London while commuting to work. It could be an aircraft engine while boarding the aircraft, etc., etc. So it could be any high frequency noise for a very short period of time that caused permanent ear damage to my ears. And I sometimes wish, what if I had noise cancellation earphones that would have saved my ears. And that's why I wanted to talk about this subject, because it's quite personal to me.
Yes, absolutely. And this is very interesting how you sort of compared microphone and speakers with the human experience and the hardware we have to listen to sound. And sound engineering is fascinating on itself. I mean, there's so many aspects of it and so many things they have to think about, and so many sort of technologies that goes behind it. It's amazing. And a big part of listening to sound is microphone. And you know, as human counterparts, we use ears to listen. And um, I remember this phenomena. This happens when you are in a party or somewhere where there's a lot of ambient noise, and then you are talking to someone, and then suddenly you hear someone calling out your name from around, and your brain picks that up. So what is happening in you know, with our ears as humans, our ears are also always listening to all the sounds that are happening, and our brain is sort of doing the noise cancellation, so we only listen to the parts that are important to us, that are contextual to us. To, you know, if I'm talking in a party, then I'm talking, you know, I'm listening more to the person I'm talking to. But then sometimes brain makes a mistake from all the ambient noise. If something sounded like that's important to us, we suddenly feel like, oh, someone called our name or something important. So the noise cancellation happens in humans, in our brains. but our ears also listen to everything that sort of comes through, ambient noise and everything else. The same thing is happening in hardware, in computer technology as well. Microphone is listening to everything, and that's probably, and in early days of recording sounds and everything, that was what's happening. And then the need for noise cancellation sort of came about, because the microphone, just like ears, picks up everything, and then the noise cancellation technology sort of weeds out all the unwanted noise, and only keeps the noise that are relevant. Now, one of the very basic technology in doing that was to just identify the frequencies which are of noise. So usually if me and you are talking, our voices have a particular frequency, and if there is a car squeak in the background or something else, traffic noise or something, those will have different frequencies. But then again, it's not always like a black and white separation. Sometimes there are overlaps and stuff. So in early days, there were noise cancellation where they would just try and identify the most of the frequencies of noises and then get rid of that. But then what you're left with is also kind of becomes unnatural, because even though our voices have mostly a range of frequency, but we still go up and down as we speak, especially when you're sounding particular character like S.
Angry or like ecstatic, etc. Yeah.
Yeah. So S and F and these kind of sounds have a higher range of frequencies. So when you cut the higher part or the lower part off, your voice also becomes a little bit unnatural, which is also not really what we want. We want our voice, or whatever is the main subject of the sound, to be clear and legible and natural. So nowadays we've kind of became more advanced in identifying exactly what it is that we want to get rid of. And I mean, sound engineering, or sort of dealing with frequencies, is actually quite beautiful. I mean, mathematically as well, because
Yes.
all of these things all of the different sounds can be a wave function, and then you can do various mathematics and various control engineering algorithms to implement those, to modify that wave function so you get exactly what you want. So because there is one beautiful, one like central thing that can express everything in a sound, that makes it really, really amazing in mathematics as well. So that's
Yeah,
another.
absolutely. And you said it. I mean, right, that whatever is music sometimes can be noise as well. And there is a difference between hearing and listening that people keep talking about. So in clubs, in where you have a very I mean, where you have a lot of people talking, where you have the music playing in the background, it's sometimes difficult to have conversations as well. But suddenly you hear your name and you are like, okay, yeah, my name has been called, so let me just go and see what's happening. So it's incredible how our minds perceive. And you said right, our ears are constantly hearing for noise, even when we are sleeping. We're constantly absorbing the sounds, and sound is actually quite wonderful. So you have sound on planet Earth, and you might have sound where there is even a slight bit of atmosphere, but you can't hear anything in space. So you need air to listen and hear things, and that's why we are able to communicate with our mouth and with the speech. And it's incredible, like how our ears have evolved to capture that. So the sound is basically compression of air, and there are hair follicles inside our eardrums, inside our ears, and there is a eardrum, and that all vibrates when the compressed air reaches our eardrums. And based on that, our brain gets the signal, interprets it, and then it tells us what we are listening. So even when I'm talking, my brain is listening to what I'm talking. So I can hear myself talking. I can hear you talking as well. So it's incredible how it works.
Yeah, absolutely. And this is another important part that I would also, encourage the audience to be aware of as well, and maybe take action based on the lifestyle that you currently have. A lot of the ambient noise that we are exposed to, some of them you were mentioning, like when boarding an aircraft or just traveling on the underground or just in a car. I mean, the decibel of noise that a car makes when you're driving, you don't notice it, but it's actually really high.
It is.
And if you are commuting in car every morning and evening to and from work or anywhere else, your ears are being exposed to these noise, which are harmful to those the hair that kind of listens to all the sound that happens around us. And these hairs, they're not like our
And even the
uh,
eardrums, the hairs and the
yeah, yeah.
eardrums, yeah.
These are not like the regular hairs we have in our head, etc. So these, once they're damaged once, that's it. They don't regrow, or they don't. There are thousands and millions of it, but once they're damaged, they don't regrow, or they don't get sort of they don't heal itself. So once you lose some of that, you completely lost it. And based on that and a few other things that happens with age, you can hear less and less frequency. And
Yes.
there are various tests available online as well that will generate frequencies of different hertz, and then you'll see at which point you start listening to the sound, and you can tell that at which stage you are with your ear health.
Yes.
So
That's
this
actually the test I had to undergo to identify what kind of frequencies. So I have basically high frequency hearing loss. So
right.
if there is ambient noise and if I have to have a conversation, say in a club, it'll be difficult for me to hear what you're saying because there's a lot of ambient noise. So
Mhm.
basically that's the, and you're exactly right. They make you wear headphones and they ask you to click a button whenever you hear something. They don't tell you what you're hearing, but they ask you to click something whenever you hear something. And I started clicking and they plot a graph and then they can see which part of the hearing or which part of the frequencies I clicked the button and which parts I didn't. And based on that, they can tell which are the frequencies I can't hear. And as you rightly said that hearing loss is actually irreversible. So you cannot recover your hearing. With age, you of course hear. So you must have sometimes seen old people asking, "Can you please repeat that?" or "Can you please be a little more louder?" etc. Or sometimes people say, "Can you please be soft? Don't shout too much," because they get perturbed. Like, why is someone shouting at me? Even though you think you're not shouting, but someone else thinks you're shouting. So it's very subjective, but it happens to all of us, and it's incredible.
Yeah, absolutely. And yeah, and that's why I want the audience to know that because it's irreversible, and a lot of the times we don't notice how much ambient noise is around us. So to just be more mindful of this, not to expose yourself as much, or whenever possible. I mean, I've spoken to a sound engineer, and every time he used to drive to and from work, he used to have like a long commute, 1.5 hour drive. He used to put earplugs in his ears when he's driving, because he, more than anyone else, knew the damage it causes and how irreversible it is. So yeah, I mean, no matter how lame you might think that is, but that is definitely a good practice whenever you're exposed to
But
loud
but
noises.
Rinat, I just want to correct you. You should be able to hear people honking. You should be able to hear vehicles coming behind. So please make sure that when you are driving, you are alert. It's good to
Oh
cancel the
yeah,
noise, but you should be able to hear oncoming vehicles. We are not recommending you to wear noise cancelling headphones when you are driving. We are just saying that be
absolutely.
mindful of it because it could be a traffic violation because you're not able to hear vehicles behind you, you're not able to hear ambulances, you're not able to hear police vehicles, and there could be a car accident, there could be some emergencies, and you might be a hindrance rather than moving out of the way.
Absolutely.
So
Yes,
please,
yes,
please be
that
careful.
it's good that you clarified that, Amit. Yes, so obviously, car is not the only place where you're subjected to ambient noise. So absolutely, and then there are many other times when you are also exposed to noise, which is part of having fun. Like if you're in a party, you also don't want to don't want to isolate yourself with noise cancellation, but you want to engage. And sometimes you can't avoid, for example, in a movie theater, etc. But whenever possible and whenever it's safe to do so, etc., then do be mindful of it. And when you can, make yourself not exposed to it, do your best to sort of save your hearing. But then, so far we've only talked about the hearing of humans, but then there are now, let's move on to the technology behind it in
Yes.
digital world. And how we, what we do to sort of cancel the noises in, for example, in this video conferencing call.
So yeah, let's start with, I mean, let's start with what we hear. Okay, and we hear normally through our ears, and normally now we have headphones, and those can be wired or they could be wireless. And then there are earbuds that go inside your ears, and they create this kind of a seal, and those could be wired or it could be wireless. Now, in order for the headphones to cancel the noise, they need to listen to the sound. So there are two sounds that are there when you are listening through an headphone. One is the sound that is coming out of the headphone. It could be music, it could be a movie that you're watching, it could be in a conference call, it could be people talking. So that's the noise that's coming out of the headphones or earphones. And then there is ambient noise. So we don't want to cancel the noise that's coming out of your headphones or earphones. We want to just cancel the ambient noise. So there are two ways you can cancel the ambient noise. And that is by placing the mic outside the headphone or the earphone. So it's constantly listening, and then it cancels that noise, and then it sends it to the headphone speakers, and then the headphone speakers just sends you what it's supposed to say: music, speech, etc. And the external ambient noise is cancelled. Now, how it is cancelled? So, as Rinat said, that there is a frequency, and the frequency has a curve. It goes up and down. You must have seen a sine curve. If not, please Google it. It's a very beautiful curve. It's a very simple curve. It goes up and down along an x-axis and along the y-axis. And when that curve goes up and down, and how fast it goes within 1 second, that's defined as the frequency. So if we see that curve when an ambient noise is coming, we analyze that using a microprocessor or a chip inside the headphones. And that chip then translates it and then inverts the signal. Inversion means it, so if the frequency is high, it makes it low. And if the frequency, I mean, sorry, if the amplitude is high, it makes it reverse. So it's like saying if there is +1, you add -1 to it, so it cancels and becomes 0. We'll share some links to show it pictographically, like how it looks. But if you can understand what an inversion means, it's simply basically negating what you're hearing. So the opposite of a frequency is what the noise cancellation chip does. And then using the speakers of the microphone, sorry, the headphone or the earphone, it sends you the signal. So that's feed forward. So it means it is listening from outside the headphone. Now, there could be also what you are listening. So that's feedback. So the mic is actually inside your headphone. So in this case, what happens is that the mic is trying to listen what you are going to hear. And if you are hearing noise, if you are hearing noise inside your headphone or inside the earphone, then it'll try to cancel that. So that's feedback. So one is feed forward, the other is feedback. And then there is a hybrid. Hybrid is basically having a mic outside as well as inside, and then combining that and trying to cancel both of it. Of course, there are pros and cons of both sides. Noise cancellation works very well when there is a constant frequency. Say you go in an aircraft, or say you're traveling the tube. The sound of the tube is always constant. It never goes up and down too much. Maybe at a turn, maybe when it's braking, it goes up and down, but no, normally, more or less, it's the same frequency. So it's easy to cancel. But if there is a sudden change in sound, say someone suddenly shouts, or say there is a high pitch wind because a car crosses, then it's sometimes difficult to cancel that. So normally noise cancellation works when there is a constant sound. So it's very good for ambient noise or a same frequency noises. But if the frequencies keep fluctuating, then it's not that good. So that's a hybrid one. And then we keep hearing about the different types of headphones, like active noise cancellation, just noise cancellation, adaptive noise cancellation, adjustable noise cancellation, and many other modes. And these are the kind of technologies that the headphone companies want you to understand. Of course, they say that okay, ours is the best, but what does it actually mean? Noise cancellation is just inversion. Active noise cancellation is dynamic. So noise cancellation, when I say inversion, is it knows specific frequencies and it cancels those frequencies only. Active noise cancellation is that it hears in real time and then cancels it. Adaptive is when you are hearing something based on your surrounding and based on what you're listening, it will adapt and then it will cancel. So it will not cancel just standard way, it will cancel based on what your surrounding is. So adaptive, sorry, noise cancellation and active noise cancellation is same. Adaptive is different, it adapts to the environment. And then you have adjustable noise cancellation as well, where you can adjust how much noise cancellation you want, because sometimes you are in the airport, you want to hear the boarding announcement, so you want to not cancel everything, so you want to keep hearing the ambient noise as well. So that's again important. And then you have something called as transparency mode. So without taking off your headphones, if you want to hear the ambient noise, so either you cancel the noise, or there is a mode called the transparency mode where you can hear the ambient noise without actually taking off your headphone or earphones. And that's transparency mode. And of course you have adjustable modes, adjustable transparency mode, and so on. So these are the different types of noise cancellations and the type of technology in which the companies are trying to sell their products. So you need to understand what kind of headphones you're buying, because based on what noise bothers you, you need to decide whether you want to feed forward or feedback, and with active or adaptive noise cancellation, because that's very important based on your daily habits and based on how your day looks like. Do you travel a lot? Do you read a lot? How's your sleep? Are your neighbors making a lot of noise? Do you normally commute a lot? Do you normally fly a lot, etc., etc.? So those are the various factors that would go in deciding what kind of hearing product you want to buy, which is deciding what kind of noise cancellation you want to have.
Yeah, absolutely. And it's amazing how in recent days there's so many newer technologies which is built upon identifying the frequencies which are of noise and which are not of noise, and then isolating them and removing them, etc. But at the core of this technology, high pass filtering remains like a basic
Absolutely. Yeah. So you want to
and
hear something and then you want to filter it out, and that the way you do it is by canceling it by
yeah.
inversion of the frequency. So yeah.
Yeah, and I've mentioned high pass filter and low pass filter earlier, a little bit, just touched upon it. But just to give you a bit more of a detail, so we have frequencies, of we have like sound frequencies. Some of them are, say, for example, us talking, and some of them are ambient noise. And our talking frequencies are usually, hopefully, different than the noise. If they were exactly the same or very similar, then it would be more difficult to identify and then isolate. But one of the benefit is usually the noises are either higher frequency or lower frequency. The high pass filter, it's the name of the filter, that lets the higher frequencies pass through, and low pass filter lets the lower frequencies pass through. And if you implement both, then it cuts off the top and the bottom of the spectrum and lets the middle part pass through. And usually that's our conversational voice anyway. And obviously, to know whether how high or how low do you need to pass through and what you need to isolate is when you adapt based on what you're hearing, that's the adaptive noise
Yes.
cancellation as you mentioned. So yeah, I mean, and nowadays I hear AI is also being implemented to identify which one is the context-based sound. For example, and it could be very different because when you're listening to music, that's the context-based sound. That's what you want to listen to, and that would have a much higher range
Yes.
of frequencies. And
Yes.
when we're talking, that's a completely different thing. And then imagine in a content or a video you're watching which has both music and conversation. Maybe it has an intro with a bit of music, and then someone talks for some time, and then it goes to like another cutaway video part which has music or sound, or a car accident video, which, and then you have to adapt these things and understand which one is context-based sound. And
Yeah, which
AI
one is
hopefully
noise?
which AI will, and currently also is turning out to be much better in identifying these context-based noises and giving us better experience. For example, in Zoom right now we're talking. Um, I think if we both stayed quiet for 3 or 4 seconds, it would be as if everything's muted. None of the noises will be transferred. Like, even though there are some traffic happening around me right now, I don't think you can hear it, Amit, because it is actively being cancelled.
It is, yeah. So that's the
Yeah.
microphone part, which we will talk later. Yeah.
Mhm. Yeah, yeah. So, I mean, I usually, when you're talking, I mute myself. But even if I didn't, I think there are technology right now at the moment being active that would kind of make my side completely quiet. And then, when we edit our videos, we also do a bit of noise cancellation as and when necessary as well. So yeah, it's ingrained in everything that we do, and digitally especially, it's kind of a default setting nowadays to have noise cancellation in any sound content.
Yeah, Zoom, Google Meet, they all have this setting where you can cancel the noise when you're actually speaking, so that if there is a vacuum cleaner running, if a baby is crying, if there is a washing machine running in your house, then they don't send those noises back to the other side. So the listener, they don't hear those noise, they only hear the speech. So that's the noise cancellation on the microphone. But I think when we talk about the headphones, because I just want to cover other topics as well, that noise cancellation need not be that when you're hearing something. It could be that you just want to cancel noise. You don't want to hear anything. You're not hearing, but you just put on the headphones and you just turn on the noise cancellation, and that's it. And you just go through the airport, you just go through the commute without listening to anything, and then you are enjoying the silence. And I think that's also important to understand that yes, some people need that as well. They don't want to hear music, they don't want to do anything, they just want to protect their ears. And it's good to have such kind of headphones so that you can enjoy the silence when you're commuting, traveling, or even sleeping. So those are the different modes. And I mean, noise cancellation is when we talk about noise cancellation, it could be also when we are trying to use drilling machines. So it's very important to have ear mufflers when you are doing some DIY work in your house. I do a lot of DIY work in the house. I have a drill machine. I have a lawnmower, and they make a lot of noise. I have a Dyson vacuum cleaner. It makes a lot of noise, and I get irritated by the sound. So now I've started wearing ear mufflers. So it helps protect my ears from the high frequency. It's not headphones, but that's what you call as passive noise cancellation. It's blocking the noise by not listening to it. It's just blocking using the mufflers, just having some foam around your ears to block the noise, and it actually works. Of course, it doesn't block all the sound so that I can hear some people coming in, etc. But I think it's very important. So those are the things that are related to your headphones. And now why this is important, because people get irritated, people get angry, people lose their sleep, people have different kinds of issues, etc. So it's very important that you protect your hearing, and hearing is one of the things that is getting abused on a constant basis, because we are now have so many devices in our house that are constantly producing sound, that we don't know what actual silence means because we are not used to silence anymore. We are just used to some kind of noise, or you, as Rinat mentioned, white noise.
Yeah, absolutely. I mean, as you mentioned, the using headphones just for silence. Nowadays, there are. I think I've heard of like this kind of some kind of smart headphones which has a microphone built in, and you are, you turn you're not playing anything, you're not listening, you're just putting them on, and they actually listens to the ambient sound that's happening outside, and tries to identify the sound that you would want to listen to, like for example someone calling your name or a conversation, etc. And that microphone noise, the microphone picks it up, and then it plays those sounds in your headphone.
Wow,
So that's I thought that was very cool.
that
I
is very
actually
cool. Yeah,
on
because
Amazon to buy it, but I couldn't really find it. And I'm sorry, audience. I know the technology exists, but I don't know where to get it myself. But yeah, I mean, say for example, you're doing vacuum cleaning, wearing headphones, sorry, headsets for noise cancellation. And say for example, your partner is calling you. You do want to hear that, right?
oh
And
yes, I think Sony has their headphones, but I don't know if it works like that. So what happens is if you take the headphone off, it stops the music, and if you tap the headphone, it automatically starts listening to
yeah,
the
that's
normal sound.
that's that's quite
Something like that.
commonplace. Like with tapping instead of buttons
Yeah,
nowadays,
yeah, yeah.
that is quite commonplace. But no, I'm talking about the microphone, integrated microphone, always listening and understanding which sound you want to listen to, and then playing that in your ears. I've heard about it. I couldn't find that product, but yeah, I mean, either it exists or someone was probably talking to me about an idea, and hopefully, if the audience can't find it, maybe they want to patent it or make this as a product. The tech savvy audience base that we have. But yeah, going back to the human experience of sound. I mean, sometimes we don't realize how important and how powerful our ears are in terms of listening to sound. And we could identify very slight change in the sound we're hearing, and a lot of even in different cultures, like the tone of someone's spoken words, we identify like whether someone is angry or frustrated or different emotions, not
Yes.
just positive and negative, happy or angry, happy or sad, but you could kind of tell whether they're frustrated, they're angry, they're sad, they're feeling hopeless, or happy, joyful. I mean, all different things you could identify with sudden, very subtle changes in their voice. And that's just one aspect of changing the frequency. But then you could also identify exactly the direction of the noise is where it's coming from. And there was a test like where 360 degrees around you on a horizontal plane, if you divide it by a degree, in a large room, you create a makeshift room which is circular, and you create like a three each degrees you divide it, you mark it, and then if you put a speaker in any of those degrees, any of these locations, and play a sound, and you're blindfolded, you don't know where the speaker is or where the sound is coming from, and the sound is played in the speaker behind you or wherever in that 360 degrees around you, you would be able to tell with 1 degree of accuracy where exactly that speaker is. And that's, evolutionary, this is built up because, we need to know where, when we're, you know, um, before civilization in caveman era, we needed to know where a
Danger is coming
potential
from.
danger is, and where that sound is, and in exactly which direction. So this is built within us, and it's really powerful, and we might not notice it, but we use that all the time. And even when producing music or movies in a digital world, we use that as a stereo sound. And when you go to watch 3D movies, there is a lot of things happening on the sound world as well. They're not just bringing you 3D visual experience, but they're also changing the stereo sounds in such a way that you experience the sound is coming from right, not just right or left, which side of right or left. Nowadays, the technology is that sort of sophisticated. So
Yeah.
yeah, it's amazing how powerful it is and how little we notice of that. If the technology is less noticeable, a lot of people say that that's a sign how good the technology has
Yes.
become. It's not supposed to be, you know, hindering your life, or you shouldn't be noticing. If you're living your life smoothly, then you shouldn't even be noticing a technology. And that's what's happening in sound world for a long time, actually. So yeah, it's really fascinating to learn about sound in general, as well as how the noise cancellation technology is making your lives better every day without notice.
Absolutely, absolutely. And I mean, of course, a lot of people might think that do these noise cancellation headphones cause ear damage or anything, and are they harmful? Are they radiations? Well, it's nothing like that. It's just frequencies and it's inversion of the frequencies. So there is no actual harm in wearing headphones. There is no radiation coming out of it, and it's perfectly safe. The some of the side effects are people who are very sensitive to certain kind of frequencies, they might feel a bit dizzy, etc. But it's in very rare cases, and it's to do with the because what happens is when the sound is inverted, it's still some kind of I mean, it tries to cancel it, but sometimes it can't cancel everything, and there's still some frequencies that are coming in, and those frequencies might be low, and they might be causing you trouble. Because the brain thinks that you are in motion, but you are actually not, so it causes some dizziness, and that's a side effect which only very, very few people go through. But this is something to be mindful of, that sometimes noise cancellation can cause this dizziness, but in general it's very safe to wear. I've tried those headphones myself at a lot of airports, and I really enjoy it. And I think if you want to protect your ears, I think that's the way to go forward. You can get an over the ear headphones, or you can get those earbuds from Apple, Google, Samsung, etc., and they are really good. Now let's come to mic. So the microphone. So I'm currently talking through a microphone. Renat is talking through a microphone. His mic is on his table. My mic is close to my mouth on the headset that I'm wearing. And they are both picking noise or sound, and they are picking the ambient noise. So there is ambient noise coming from my laptop fan. So I'm currently recording this video from the laptop, and there is ambient noise from the fan that's coming. I don't know, Rinat, can you hear that noise? Say yes or no.
No, I actually I'm not hearing anything else apart
So,
from your voice.
yes, so the basically the microphone has a soft like a cushion or foam around it. So I think that's trying to do passive noise cancellation from the microphone side. And now there is technology that does active noise cancellation. And that means that whatever speech that is going through the microphone and the ambient noise, the software then sends only the speech and not the noise, and that's what is done by the software. So Google Meet, Zoom, and the Microsoft Teams, they are actively canceling the noise that's coming from your microphone, identifying what frequencies are the speech. As Renat mentioned, it's free frequencies or within a range, and anything above and below is not I mean, it's a noise, and then let it pass through. So that's again active noise cancellation, but that's through software. And sometimes, yeah, go ahead, sorry.
Just wanted to sort of put out this example that I just thought of, that once I was talking to my partner in WhatsApp, and I wanted to show her a music that I liked. And I was playing that music on my computer while on my phone on my WhatsApp, and she wasn't able to hear the music at all. And that was because WhatsApp was completely, like through noise
Canceling.
cancellation, completely canceling the music that's playing loud around me. But she was hearing me quite well. So that's how well the noise cancellation has gotten digitally. That there is, you know, loud noise well, in this case, I was actually wanting my partner to listen to that music, but she wasn't able to at all. And I was quite impressed, but also annoyed at the same time because I didn't get what I wanted to do, but I was impressed with the level of noise cancellation and how good it has become. So yeah, I mean that's these are I mean, but you were I mean it's an important distinction. I think as you mentioned, Zoom and these video conferencing. There are other ones like Cisco and Blue Jeans, etc. Um, but they are doing it digitally. But we also have various mechanical or physical ways of noise cancellation. And in musical world, there is something called pop shield, which is placed right in between the mouth and the microphone, which kind of filters out the various popping noise that happens when we are talking, like the S and the T, etc. So there are all of these mechanical, the foam around your microphone, all of these things are mechanical devices that are kind of doing noise cancellation. But then there are digital ones that you also just mentioned. Yeah. So yeah, continue.
So, yeah, absolutely. I think I was about to get to it, but you mentioned it, which is very good because I mean, there are a lot of people who watch or listen to podcasts and they hear crystal clear sound. And how do they achieve those crystal clear sound if they have so much ambient noise around them? So sometimes they are in a very soundproof room where there's actually no noise. They make sure that any noise coming from their machines are actually cancelled, and they use noise cancelling headsets and they use noise cancelling microphones. One of the ways is having a plate in front of the mic. So you must have seen a lot of podcasters. It happens where when you listen to singers recording in a soundproof room, so they try to have a plate in between them and the mic so that no hissing sound or all those sounds are filtered, because or take just taking in a breath. So I'm talking and then I take in breath and then I continue to talk. So that sound itself is kind of noise, and you don't want to hear that when you're singing. So they actually cancel those noises through this plate. And then of course on the microphone itself, so a lot of podcasters and a lot of people now on who are working from home, they have professional microphones. So there is a microphone from Blue Yeti, which is I think the most common one. I think Rinat, you mentioned you have a Blue Yeti microphone. Do you have a Blue Yeti?
No, no, the one I have is Rhodes.
Rode,
Although
yes,
I'm not
Rode
using
is
that one right
another
now.
good company. Yes,
Yeah,
yeah.
yeah, I'm not using that right now. So just FYI, audience, this is not an sound sample of Rode
Rode.
microphone, but yeah, that's the one I use a lot of the times.
So yes, so that's there is Rode, there is Blue Yeti, and there are many other companies, and they on their hardware. So when they pick up the sound on their microphone, they also pick up the ambient noise. They cancel the ambient noise, and then they transmit that sound through the cable or wirelessly, and then they record that sound on your computer, and that's how it works. And it's incredible how, and it's the same principle. So you have a microphone, it picks up the sound. You have a chip that inverts the noise. It keeps the speech part. And it cancels everything else, and then it gets recorded. So, and the listener on the other side hears only what's needed, and everything else is cancelled. So it's a very simple thing, but it is very powerful. And these days, it's now getting in more and more headphones and microphones, is because of the technology. The chips have become very powerful. They've also become very small. So you can put a very small chip inside a headphone and still get active noise cancellation, because these chips have to do a lot of calculation. They have to listen to a lot of frequencies. They have to differentiate between human voice and many other ambient noise. They have to analyze that. They have to invert it. They have to send it back. They have to listen. So they have to do a lot of these things. And these chips have to be again very small so that they fit in a very compact space. The headphones itself have to have microphones. If you're wearing a if you're wearing a wireless headset, they need to have a battery. The battery, if you're using noise cancellation, the chip is consuming power. So there is a lot of the battery consumption increases. So a lot of times when headphones are being sold, they advertise that with active noise cancellation it's this much battery life, without it it's this much battery life, and etc. And with microphones, normally what happens is you're plugged in, so you don't have to worry about batteries. If you have a Blue Yeti or anything, it's USB or you can plug it externally. But with microphones, normally you don't have a problem of the wireless part. It's only with the headphones. So the technology has improved a lot. It is now making sure that these podcasts can be done by even people like us, but very professionally with very low budget equipment. I don't have a very fancy headset. It's just from Microsoft. It costs about 30 quid, 30 pounds. It's not very expensive, but it does a decent job. And it just shows that you don't need very expensive gear to start something. You just need the will to start. So, yeah.
Absolutely. So yeah, this has been like a great talk. To be honest, I've learned a lot from you through this talk as well. Hopefully, our audience did the same. And yeah, I also enjoyed sharing some of my stories from the past. And it was all of these things sort of came about as we started talking about noise cancellation, which I didn't thought about for some time. But yeah, it's fascinating to say the least. All of the technologies that are currently there, and it's actually quite it's not like a very recent outburst of technologies with improvement. I mean, we've always had as soon as there have been sounds, there was need to cancel the sounds that we don't want to hear as opposed to the ones that we do want to hear. So yeah, it's been really nice talking about it with you, Amit, and hopefully the audience enjoyed it thoroughly. And if there are any aspects that you didn't like or liked, do let us know. Our contact details are available in whichever outlet you're listening through. Um, and we would take that on board. And if any future topics that you guys would like us to talk about, do let us know as well. Yeah, thank you again, audience, for constantly letting us know the ones that you did, and we look forward to coming back to you guys every week with more and more episodes on different topics.
Well, thank you so much again, Rinat. It was really great talking. I really liked some of the examples because I think it's very important where to people for people to hear real life stories because that's how they'll relate to it. Technology is there to help us to augment our senses, and noise cancellation is one of the technologies that's helping us, helping a lot of people who have hearing problems, and also in protecting their hearing. So that's why I think it was great talking to you. And yeah, listeners and viewers, please do let us know how you feel about our podcast, and do give us any feedback that you want, and do recommend us topics. And as we promised, we will be with a guest soon. So please keep listening and tuning in, and hope to see you next time. Thank you.
Thank you, everyone.